Awesome. We're in a forward loop there. Welcome everybody. Thanks for joining. Nazar and Vasyl, thanks for being on board. I'm sure people are starting to join here. So yeah, we want to kick off slides and then I'll introduce everybody.
Hello, everybody. Can you see my slides at the moment?
Not yet.
It should be
There
done.
we go. Yes, I can see it now.
Terrific.
Awesome. So thank you everybody for showing up to Cyber Resilience 201. For those of you who showed up to 101, we talked about kind of basics of cyber resilience and cyber resilience engineering. Now we're going to do an episode focused on AWS and kind of some of the security pitfalls and the resilience issues that you're going to run into when you're engineering for AWS.
And today we'll try to really make a great demo, which will explain also a typical path used by malicious actors to take over AWS environment, and also like crash this myth that AWS guarantee you security and other things that very often people misinterpret when they think that they are moving to the cloud and the security mission is done. We'll also heavily focus on a MITRE and attack simulation. And here is a few words about us.
Yep. Yeah, so Airiam was born out of being an MSP and morphed into a security company and a resilience company over the years. And we really focus on incident response and post-breach recovery, disaster recovery, and managing your backup situation, and continuing managed services for on-prem infrastructure, cloud infrastructure, private cloud, hybrid infrastructures. And we also have a large digital transformation team that does a lot of custom coding, DevOps, architecture stuff, as well as integration work between, complicated legacy systems and things like that.
One of the things I would kindly ask you to emphasize is about your ransomware guarantee.
Oh, yes. Yeah. So we've been on the front lines with ransomware for the last 5 years. We handle most of our incidents through the cyber insurance channel. But when we have our services in place, we offer a ransomware guarantee where we will handle recovery, up to $2 million worth of work on recovery in order to get you back up and running. And if you are managed through us, usually it comes nowhere near that because we're managing your environment tightly and we can restore you very quickly. But we have now the number is closer to 75,000 hours in ransomware recovery. And, so our team is frontline every day, handling between 6 to 10 incidents all the time.
Well, few words also about UnderDefense. So we live in the world of detection and response. We love hunting for threats and also doing some piece of like forensics and automation work. So like Python and automation are part of our DNA, but we use it primarily to automate the things to minimize time required to respond to cyber threat or to the incident, and to enrich the each alert with the proper context to resolve it quicker. Also very proud to have our team as a number 4 across both of the SOC competition this year, and being a number 1 in a managed SIEM provider according to Comparitech. Art?
Yeah. So one of the things that I want to illustrate is that there's a difference between cyber resilience and cybersecurity. Cybersecurity is really the foundation for resilience. If you don't have cybersecurity, you're going to be fighting the same battle every day. You're always going to have a problem with preventing an attack. But cyber resilience is really your ability to bounce back. That's your recovery. That's IT infrastructure watching and well architected design. and the ability to flex under an attack and bend without breaking. So both of us come together, Airiam and UnderDefense, in partnership is a perfect combination to give you a whole solution of brilliant IT architecture and recoverability on top of security that will actually understand your situation.
And like why we talk about it today, especially in the AWS context, it is because like we see the like it's trend not rising. It's already going on, and if you don't realize that year over year, it's like according to Cyber Assets report, it's growing to plus 598%. It's huge. It's and this is happening because government, uh private businesses, non-profits, all everybody don't want it to mess with on-prem infrastructure anymore. It's time consuming. Cloud is so cool, so useful. Still, like that myths that like, hey, AWS have this shared responsibility model, but under shared, we expect that they will taking care of it, and taking care of compliance and all the other things, while we will just build an apps or like deploy our like WordPress or whatever we have, and like mission is completed. So the problem is that like the attack surface for cloud native applications is increasing dramatically, and attackers are targeting these misconfigurations in the cloud infrastructure, including network, compute, storage, identities, and permissions. The problem is huge, and that's why we talk about it, because we want to show how these problems impact like huge organizations, and how they can impact your like businesses as well. And it's in the news year over year. Today we'll show you the case of which happened in 2019 for Capital One. But this is funny because it was a former AWS employee who breached into Capital One, who penetrated in the Capital One environment, because he was a DevOps guy who knew how to use AWS toolset, and he was not. It was not sophisticated breach. It was not sophisticated set of commands. It was not no 0 days. And again, it's in the news almost every day that somebody is exposed. 123 millions of US households due to misconfigured AWS S3 buckets. It's funny because S3 shouldn't be a problem in 2023. Still, it
No.
is. Uh, um,
Yeah, let me explain the MITRE frameworks, but yeah, let me just touch on that real quick. There are a lot of tools and a lot of understanding now that S3 needs to be configured correctly, and yeah, it's every day that you see a new breach due to a misconfigured S3 bucket. So it's definitely something we need to address as a whole with DevOps and IT personnel. But yeah, MITRE is a organization. It's a nonprofit, but it's funded mostly by government projects. Some third party, but they've developed several frameworks, and these are just some of them. Attack, Defend, Engage, Caldera, and the Cyber Resiliency Engineering Framework, which doesn't have a cool name, so we just call it CREF. You're probably familiar with Attack. That's really mapping your TTPs and understanding your threat actors and kind of the behaviors that they do. Defend is really defensive countermeasures, and I really like Engage. Engage is cool because it's all deception. So that's a framework I'd love to start using. Caldera is really an automated pen testing platform, and I'm really becoming an SME in the cyber resiliency engineering framework. And that's really what I'd like to use to map recovery and any kind of well architected solutions against. So when you hear me mentioning MITRE CREF for resiliency, that's what I'm referring to.
and I wanted to add from my end, like in the world of IT over the last decade, we have seen that have been many standards, like many drafts, documents, recommendations from NIST and other like very solid institutional organizations that were producing like 250 pages documents, and most cybersecurity professionals have troubles reading these huge books, during their day or night. And that's why solid frameworks like MITRE making a difference. It's easy to use. It's very visual, very explainable, and that's why we use mention about them and how heavily recommend during our cyber resiliency series. Um, so in our demo, we wanted to also showcase how the attacker is, could impact, any cloud environment, and every hack against cloud have the typical techniques and tactics used to achieve the malicious goals. And typically, it's about initial access, uh, execution, persistence, discovery, and impact. And when like further on, my colleague Vasyl, who act as a senior DevOps professional at UnderDefense, a highly certified cybersecurity and cloud architect, he will showcase some of the elements of the skill chain, including this initial access, uh, information gathering, like initial access to some web application vulnerability, which happening every day. I guess you have read many stories of it. But about stealing credentials to a cloud environment and having these keys to the kingdom, using these keys to enter the kingdom and raise their privileges, to take over the crown. It's a real threat that we wanted to emphasize and showcase today. Uh, so let me stop sharing and shut up for a second. The floor is yours. Please share your screen.
Hello, everyone. Hello, LinkedIn. I'm super excited to be here. So in this demo, we are going to showcase Capital One breach. So this is UnderDefense Maxi platform, threat and incidents page, and there is no incidents yet, but as we progress with the demo, there should be an incident. On the second tab, I open a web server, and this application is vulnerable to server-side request forgery attack. And the attacker is going to complete the URL query in order to steal credentials from this EC2 instance. So he just copy role name and complete this URL. And here you go. Credentials from incidents metadata service has been stolen.
And you see,
in a second,
it doesn't require any specific tools to do this. It can be done by any kit in the internet. Just like it's a very typical vulnerability, but it happened.
Exactly. So, and the main issue that you might see that this web application has been put in public subnet, so it's publicly available. So then the attacker complete the same query in order to get credentials in a CLI session. It's just easy to copy and create environment variables. These environment variables AWS access keys and secret keys and then token required for AWS CLI tool. And this is a tool provided by Amazon in order to interact with resources from your local computer. And then attacker verify that credentials are valid, and actually he managed to get access as a cloud attacker demo role. So, and what happens next? The attacker is enumerating resources in the cloud. And pay attention, by the way, he's got read-only access. And you might ask, what is read-only? It's about nothing. But wait a second. The attacker enumerate S3 buckets, and in a second he is going to find a deleted file from S3 bucket. And this file contains another portion of credentials. So let me speed up a little bit. So he found credentials, then he's going to create another profile for AWS CLI. And now the attacker is EC2 SSRF demo admin user, and we just about to verify that he's got administrator access to your account. And you can imagine what can happen next. Attacker can delete resources from your account or just shut down entire infrastructure. And it also was to mention that his actions won't be noticed for 18 minutes, while cloud-native services in AWS are going to detect unusual behavior in your infrastructure. So I will speed up a little bit until the end of the video. Here we go. And you see that UnderDefense Maxi platform detected unusual behavior, which is unauthorized access, instance credential exfiltration. And we also enrich these incidents with additional data. And we created issue in our tracking system and the respective security engineer is going to investigate these incidents and remediate it for you.
So in addition to like just thinking about the misconfigurations and the fact that this app was publicly available and the fact that you know, there were keys exposed, even if they had been deleted in an S3 bucket. Beyond those misconfigurations and things like that, the fact that 18 minutes was the time that it took for detection to happen through the AWS system, that kind of shows that AWS is not perfect, is not fast for the security side. It had to process that for, on average, it's having to process for 18 minutes before you receive an alert. So that's just going to extend your initial detection out, which is going to lengthen out your entire process of response.
Exactly. So this is something that we are going to improve in our future.
So what we could learn from this case, Art, from your perspective?
Yeah. So something to think about is that the cloud is just another computer. You know, you've probably heard that or seen that several times, but you know, any kind of exploit that you can run on a server that's in your building, you can run in AWS on a server in AWS. AWS is also not responsible for your security. They have a shared security model. They're taking care of their stuff. Everything you put in AWS is your problem. And your data, your connections to your systems, any infrastructure that you spin up and configure, it's all your responsibility. So a lot of people, when they move to AWS, they think they're shifting risk. They're really shifting their cost model from being capital expenditure to operational costing, but it's, you know, you're turning it into a monthly bill, but it's you're not shifting risk, you're changing the risk. And one of the problems with AWS is a lot of people, well, any cloud infrastructure, when you go to cloud, your internal IT is used to managing your internal VMware environment, your internal, you know, physical server environment. They are probably not skilled in all the complex systems in AWS. They probably don't understand really how to lock down and configure that properly. So you're looking at a different skill set. Ransomware is still possible in AWS. You know, machines can still get infected if you lifted and shifted servers to AWS. They're still susceptible to ransomware. If you have storage mapped directly to a server in AWS, it can still be encrypted. Resources can still be hid in AWS through a VPN to on-prem. There's a lot of vectors and ways that we've seen that happen. So it's time to start thinking about really a new approach is what are the right tool sets to be able to identify a cloud incident and to be able to resolve a cloud incident. And the cloud represents a certain amount of agility. Everybody now has this amazing ability to be agile and do all these things. But, can you pick the right tools and the right services to actually set up a resilient architecture with the right security so that you can respond quickly and so that your infrastructure is safe? And most companies still are having recovery problems. We've seen that over and over again. Latest breaches that have been on the news. When there is a breach, and especially if there's ransomware or if it's a destructive malware or a destructive event where the deleting a tenant, that kind of thing, a company has a lot of trouble recovering from that. Most people don't have backups set up in a way that they're in a different tenant, that they're in a different environment, and they're able to recover. So the 4 key pillars of AWS cyber resilience is, well, number one, we want to prepare. We want to think about hardening the environment, checking your configurations, using automation that is set up for secure automation of configurations in AWS. Regularly review that, do risk assessments, vulnerability assessments, penetration testing, etc. But harden and fine tune. Set up 24/7 threat detection, because the attacker does not sleep. You need to be able to respond. So, AWS may send you some alert if you set up your alerts properly through AWS Security Hub. But as we see that can be a while until you actually get an alert. But do you want that all coming to your email at 3 a.m? You need to have a team to support you. Professional AWS hacking exercises are really kind of, hire the right team for pen testing. Hire someone who knows how to attack web apps, attack AWS. Use automated testing and things like that as well, but leverage a professional team that is able to actually attack the environment so that you can actually effectively test your resilience. And then test your recoverability. And you can do this with chaos engineering. You can do this with chaos generation. But you can also do it from a security standpoint. What happens if this machine has ransomware? What are you going to do? What happens if this whole tenant or this VPC is no longer there? How does that affect your environment? What if somebody got those admin creds and deleted resources? Things like that. So how are you going to recover? How are you going to redeploy? Do you have AMIs of any servers that you have, any images that you're able to redeploy by code? If you're using third-party backup solutions, are you able to redeploy it by code? And can you test that? And I would encourage you to test in production. If you can't test recovering a system in production, then you're never going to be successful when an actual attack comes.
And Netflix is a great example of company who really loves this crazy exercises to to first test the quality of work done by their engineers. So they have this Chaos Monkey tool to hit a big portion of their infrastructure and quickly recover it as a code from the pre-built, well-prepared images, and as well as I haven't heard about many other big solid firms who actually do things like that. And this is that's the case. And from my perspective, it absolutely makes sense first to always as a business owner or stakeholder to ask the things if to your DevOps or IT people do we have an immutable backups and infrastructure as a code to recover quickly? And if yes, I'm always asking for evidences, because
Yes.
people say yes, do we have incident response plan? Yes, we have. But very specific question about how quickly we can get online in a worst case scenario. Be conscious not to get the be careful not to get the round number, right? 20 minutes. 20 minutes is the more important question is what was the last time you tested it, and what was the outcome, and who was
Yep.
involved, how many people were there, because
Yes.
it's a matter of time. Like if it's happening during the night, well, you have a trouble. So like from my perspective, based on the customers and prospects we dealing with, we see that like a big ego very often can kill a very good business or infrastructure. So like wearing multiple hats will need to favor, because you can be a hacker plus DevOps plus SecOps. It's a different role, different skills that you can practice like all of them simultaneously. You can't. It
Right.
doesn't matter of time. You can be a superhero in the number one. And security and DevOps are not the same as many people expect, and it's not just about like detections, because AWS provided great, products to have these detections. It's also about the readiness to respond and knowing how to what to do when it happened. Um, it's about the understanding that infrastructure, the bigger your infrastructure and deployment becomes, the higher is the risk. Because I
Yes.
have seen the technology companies with huge cloud deployments, because cloud first was a part of their business strategy. Like many organizational units uh, had their own cloud servers, like terminal servers and other things that were purely hosted in AWS.
Yes.
And they have their separate accounts, and managing all the accounts simultaneously is a it's painful,
Yes.
and you can't be like up 24/7. Cloud detection response is require is a specialty, not just a hobby. It's very hard to understand for very ambitious people who knew like what they do, but sometimes you have to give something to people who are masters in it.
Yes.
For example, cyber resiliency engineering in AWS,
Yep.
not that easy thing.
Yep. And I'm all about, a cross-functional team. I want experts like Vasyl to understand security and to understand DevOps and architecture and networking and systems. Like, I really want a cross-functional team, but I can't expect him to be an expert in literally everything. I need somebody to really buckle down on security with AWS. I need someone to buckle down on IAM and understand how the identities and roles work. I need somebody to really understand, the IT operational efficiencies and things like that. So, that four eyes approach definitely is needed. Two eyes that are your DevOps engineer and two eyes that are your SecOps engineer, in order to really pull this off well. And not only that, but if you have one person doing this all, there's a lot of succession risk. There's a lot of problems. What if that person leaves? Now all of that knowledge is gone. So definitely approach configuration with two people and consider how complicated this is. Now, one thing that Nazar spoke to is that he's worked with clients that have very large, complicated environments. I've been pulled into recoveries with AWS situations where there's been 100 different accounts and tenants, basically because of mergers and acquisitions, where people will acquire a bunch of other companies, and each company has 10 different accounts, and there's no unified management. There's no control policies, no SCPs across them. There's no configuration management, no monitoring. Half of their environment is unsecured, and DevOps may not even have creds for half of the stuff. So it gets complicated the bigger you get. So reducing that footprint is definitely an initiative to take back home. If you have a large enterprise that has a wide footprint there, just think about the amount of risk you have in managing that.
And AWS actually is a great platform. Like all three of us, love the platform. It's equip you with all the best tools to complete the mission. But the key problem we face, like dealing with like this complicated customers, like with their like great, brilliant, but sometimes simplified, sometimes overcomplicated infrastructures, is that like dealing with all these tools, like this 4 hours approach, it require alignment. So alignment is the key problem that every organization have, despite like the industry. You need to like have separate people who are dealing with security and who dealing with uh, uh, all the rest of the ops part, and again aligning what are the outcomes for each of this company. You see, like there's various layers of protection for organization, for org unit, and for an account, and in each of them there is resources, principles, and network and content discovery. So you see, like each of these tools and components on AWS require a very deep knowledge and alignment of the things that you configured here to the things that you configure here and here, and they have to play together like an orchestra. Because like you can have your directory service and you can have your cognito, and like it's a two separate products. So it's again, it's all for cybersecurity. It's all to complete various elements of your mission. But again, you can imagine how many you can count how many of these tools are available and how many of these tools have to work together. And you see that, as example, AWS Security Hub becoming a central place to complete the mission. But it's still not that easy. And like based on a demo Vasyl provided earlier, you can see that it is taking that minutes to grab the valuable insight and bring it to in front of eyes of SOC analyst or DevOps guy in the middle of midnight. So all the things like key management, all the things about like your deployment, it should like your people, your support staff, if you have if you're putting this responsibility to react on an incident on their shoulders, they need to know your infrastructure very well. And it's also about the traffic flows between the VPCs. It's about the like specialty who have to analyze if your DNS is configured properly, if your certificates are correct and up to date, and not stored somewhere on a S3 and then later on have been deleted and recovered by some malicious actors. So there is a tools to solve various problems. CrowdStrike Falcon is one of the best one to rely on, and still it's require like a person because tools cannot think. Tools can react on the patterns, while people can actually analyze, communicate, and investigate. Um, so if we speak about the resiliency, I don't know anyone better than Art who can explain it easily. Like for my mom. Art, please go on.
Yeah, absolutely. So yeah, first we want to think about this is an incident response life cycle here. So preparation, detection, analysis, containment, eradication, recovery, and post-incident activity. Now, if we map those to that MITRE CREF that I was talking about earlier, we're anticipating an attack, we're withstanding from an attack, recovering from an attack, and adapting and learning and improving your environment after an attack. Now, one thing that I want to mention is that preparation is that understanding of all those tools you're using and the proper configuration of all those things and documentation of all of that and understanding what your assets are and things like that. And I understand that if you're cloud first, ideally most of your environment is ephemeral, so you can redeploy it. You should have everything scripted so you could redeploy your entire environment. And that's a part of the preparation phase. Can you rebuild your VPCs, all your networks, all your connections, all your firewall policies, all your service control policies? Can you rebuild everything by script? You have that documented so that if you're on fire tomorrow and we need to redeploy your environment to another tenant or to another region? Can we do that? Do you have everything scripted so that I can hit play and go? And then as far as the security of it, have you gotten it to a point where you think that you've actually, you understand each of those technologies? Because there are a ton with AWS, and they're very easy to misconfigure. And a lot of people think they're an expert, and you may be really good with configuring Amazon AWS's WAF service and the firewall policies, but not really understanding how the key management service works, things like that. So do you have the required skills and everything there? And do you need to bring in third-party tools, Wiz, Orca, whatever, to do some security validation on your environment? So, and then patching any of your, if you do have any kind of VMs, that if you are still running servers in the cloud rather than going serverless and infrastructure as code, if you are running servers, make sure that you're stateless wherever possible so that you can redeploy them, you can scale them with scale sets, etc. We want you to be able to be elastic and have AMIs of any server that may need to be redeployed. So here's kind of a situation that we've run into a bunch. We've done recovery for SaaS companies before where thousands of servers are affected and encrypted. And, problems that we've run into is there is no segmentation. People are just deploying all these servers. Everything has access to everything. There's no monitoring. Nobody's actually watching it. They're just assuming AWS is secure. I'm just going to deploy my servers. Everything's good. Nobody built any security automation, so there was no way to respond automatically or redeploy anything or scale anything. Ideally, if the server isn't attacked, you kill that server and then nuke that identity that's attacking it. There's no automation in place, and there was no detection or response. The servers hadn't been patched. They had been deployed years ago and were never patched, and all the backups were in one place. And that entire environment was leveled. Everything was affected. All their services were down. So when we rebuilt their environment, we had to introduce microsegmentation. No server could talk to any other server. Everything could only talk to the core services that were the endpoints that it was given authorization to speak to. So every single server was microsegmented from every other server. So if one server was attacked, it couldn't affect anything else. We put in full monitoring so that every log from that server, is going directly to a SIEM. So every Windows event log, every EDR log, etc. Deployed EDR and XDR. Put in some SOAR automation so that we can isolate hosts. We can turn off the network. We can turn off kill an identity so that we can block IP addresses, etc. And we implemented daily patching. So I know a lot of people are saying, well, if it's a Windows server, they only have patches once a month. But there's all these other things on that box, that may be issuing. Maybe Java, for instance, may have an update need to be patched, etc. So let me take a second here and talk about daily patching. People are afraid to patch. Everybody's afraid, oh, my environment's fragile, my production will go down, etc. I dare you, everyone, to patch as frequently as possible in production. It's a resilience test. If you can't patch your boxes, you're never going to survive an attack. You should get in a rhythm where you can patch your boxes. And if a patch goes wrong and your app breaks, or if the server doesn't boot, roll back, restore from backup. You should have these automations in place. And this is your test. Patching is your resilience test. And so when we're managing clients, we go through that kind of evolution so that we put in that microsegmentation, things like that. And here's how that maps to MITRE. So that all of these concepts are mapping to segmentation, analytic monitoring, coordinated protection. And MITRE gives you a ton of options. Like there's, adaptive response, dynamic reconfiguration. You can do protected backup and restore. Where, hey, something was affected and detected that, let's restore it automatically, things like that. So dynamically become aware of threats and assume non-persistence and things like that. There's a ton in this framework that can really help you build the right solution to be resilient. And one of the things to think about is your security tooling as well, not just your IT infrastructure. Everybody puts a load balancer in front, builds out a scale set, sets up their servers to be stateless and scale horizontally. Great. What happens if your security architecture goes away? What happens if that link to your SIM is broken, or that integration, that S3 bucket that all the logs are being dumped to, that then is getting picked up by your automation or your SIM? Let's say that is deleted or removed. Are you able to continue? Are your APIs built to scale, et cetera? Like if somebody takes down an API service, do you have a backup one that you can point Cloudflare or Route 53 to? Is that something you plan for? So there are strategic design principles which came out of CREF, and this is all in this NIST document, 800-160, Volume 2, Revision 1. It's one of those 300-page documents or 260 or whatever page documents like Nazar was referring to. But it really kind of illustrates these 5 things. Focus on common critical access. That's your directory, your IAM structure, your Active Directory, your key management system, your storage, your common critical assets. You may not have looped them into crown jewels initially. Your crown jewels you may think of as being your ERP system or your finance system, but everything that you have in your infrastructure may depend on these critical assets. So those are what you need to focus on. Support agility and architect for adaptability. So that's what I'm talking about when I'm talking about build it to be non-persistent. Build it, have AMIs of every server so you can nuke them at any time. Those should be common practices at this point, but it's not. People just move when they're developing. They move at the speed of sound, and they leave a mess behind, and it's in AWS where everyone can attack it.
And then they leave the organization without no documentation and without people who are coming after them, they make this palm face saying it to what should I do with it, and then there's just leaves this part of the infrastructure as a legacy and trying to rebuild everything from scratch according to their experience. And it's meanwhile that older segment may face the cyber threat.
Yep. And this is a Phoenix project concept too that everybody who's in DevOps probably loves and knows, but make sure that security professional, or there is a security professional in that DevOps team, so that when those DevOps guys are moving really fast and deploying stuff and spinning up new servers and stuff, they're aware of them and they know they need to be secured. Because I've seen many DevOps environments just go and sprawl and build stuff, and it's great and it's amazing innovation, but there's absolutely zero security. And you ask the security guys and they're like, yeah, we didn't even know they deployed that app. So they need to be a part of your team, not somebody you pass it to, not somebody that you say, okay, now security can look at it. Now it needs to be a part of your team. Reduce attack surfaces is another key thing. So as we're in the cloud and we're sprawling, there's all these AWS services, making sure they're locked down, making sure they're not publicly available, making sure that services that you are making publicly available are intentional. Be very intentional about when something is publicly available. This API service is going to be publicly available and nothing else, that kind of thing. And reduce your attack surfaces for identity too. That's, as we're seeing with Okta breaches and things like that, there's a lot going on there. Assume compromise. Always assume that someone's in your system. Chances are someone's already has your creds, already has access to your environment. If you assume compromise, assume that someone has access to your environment, how does that change what you do today? Oh, now I'm going to back up my code and get another copy of this and practice deploying it because my environment may not exist tomorrow. Let's try, think like that. Imagine there's a threat actor in your environment right now. You don't know where they're from, what organization. You have evidence that they're in your environment. You don't know when they're going to do whatever. They may just watch for forever, but they may decide to take you down tomorrow. What does that change in your behavior? How does that change how you change your architecture and your approach? And expect adversaries to evolve. This is huge. So many people are just like, oh, EDR stopped it. Oh, we're in good shape. Or, we were under attack, but, we redeployed this service and we're in good shape. The attacker doesn't stop just because you stopped one attack. They want to hack you. They're going to keep going and find other avenues. They're going to fish somebody else. They're going to come find some other app to work on, find some other service. So expect them to evolve and expect their skills to evolve, just like yours are.
And it's brilliant. Thank you, Art, for like emphasizing on these details. What I also notice during my career, IT people, people who have all the badges on the wall, like very often they are like this arrogant and self-confident. So like they are the most suitable targets because they own the keys from the kingdom, and they're the most handling the biggest part of responsibility if they do something wrong, and they should be very conscious and very careful with everything they click, with everything they download. Like there is a common misconception that I'm on Mac, there is no viruses on Mac because Mac doesn't have a Mac Defender or other things like Windows Defender have, right? And it's about and Linux can be hacked, or like Linux doesn't have anti-malware. It's wrong assumptions based on like the historical development of being an opponent to Microsoft stack or things like that. So adversaries evolve, and IT people are often also a target for very sophisticated but quick attack, and you wouldn't even know that have been breached. On the other hand, we helped like during the years a bunch of customers who were coming to us because they in their request on our website, they in a form they wrote, we got the report from FBI or security service that our infrastructure has been hacked, and we need help to identify how does it happen, what do they do in our infrastructure. And it's about being prepared and ready, and all, like, it's not just about the cloud, it's about that somebody, a third party, notify you because they are watching the threat actors, what they got under their umbrella, under their control, and they can notify you. But hope is not a strategy. You can hope that somebody will take care of your security. Yeah, here is also a great combination of what can be done so what should be done as part of devs, sec, and ops as a key elements. It's under like, and this is perfectly great explainer what should be done also in a Capital One case. It's about application code and artifact scanning and securing the API and exposure scanning, because like SSRF was an easy to discover thing. That they had a problem with application security on the beginning. Then it is also about the runtime protection, about like cloud workload and network segmentation and over expressive permissions on instances, and also exposure scanning plays here a key role. And Vasyl also mentioned about the infrastructure as a code and Kubernetes security. So like there are plenty of products to complete this part of mission, but again, infrastructure as a code and scanners to do this can help you a lot to understand where are your weaknesses, where are your problems. MITRE equip us with all these frameworks I mentioned on the beginning. and like both Airiam and UnderDefense utilize them heavily to like during consulting and also during the detection and response. I wanted to quickly like mention about some of these elements, but before that, again, I mentioned about the response. Response is a hardest part because if we assume a breach and if we have done this preparation, still response require practice. Practice
Yes.
your defenders, the guys who can quickly spot that there is a threat in the environment, and the guys who have a keys from the kingdom and who can open the door and start fighting with the fire in the room. And communication with stakeholders and speed to containment and re-education should be done should be significantly increased via automation. So this is where we step in, and as example, we heavily rely on MITRE Caldera with utilizing of our like pen testing experience to replay similarly to what was so demonstrated on the beginning, replay all these key tactics from the MITRE to check the visibility. So MITRE Caldera is a great tool. You can rely on them. You can rely on Red Canary Atomic Red Team tools
Yep.
on a GitHub to test your cloud or on-prem environment. On the other hand, like very often, like if you misconfigured or if you have like just run a dummy tools without the proper understanding what do you do, just automated scanners wouldn't sync. So as example, like there is a good scanners and there is plenty of open source which require also a solid polishment. So I can recommend, as example, there is a great company called Resilient. They built a product to run the cloud attack simulations, and they have various scenarios that could and should be tested in your deployment to validate if you can, if your guard duty and security hub have the right detections to spot this needle in a haystack. And it's also about understanding your exposure as a company and what resources, domain certificates, applications you are hosting. And it's not just about the AWS, it's about the other things like your SaaS stack, like your Office 365 and Google and HubSpot or Salesforce. Because attackers, if they gain access to, if they manage to raise their privileges, they can do many really harmful things. They can take over. They can create accounts in your Linux or Windows environments, and then find other secrets that will open the doors to other treasury for in your environment. So it's very important to understand the interconnection of the sequence in time, and also the impact of this or that actions against your resources. So our recommendation, documentation is the key if you're onboarding an MDR vendor. Asset management and knowing what are the critical assets and what are the business critical elements of the infrastructure that need to be recovered, and testing those things together with your security and DevOps team is vital for every company survival. So like MDR can really reduce MTTD from 18 to 2 minutes, but it requires a lot of solid security hardening, testing, and reconfiguration from both sides. I wanted to leave a room for questions. I guess we have like 5 or even 15 minutes for your questions. Please articulate them to us, and we'd be more than happy to provide all the answers.
Awesome. Here's one. So in the context of this enterprise complexity that you described, is there a use case for keeping separate AWS instance or a separate AWS instance? So I can say that I prefer to have a second one, to have two, and usually I will set up my infrastructure so that I'm really using that second one for resilience, and in case my creds are compromised for the first one. But that's my approach. But you may need to do it just because you're reaching physical limitations with AWS too. So depending on the scale of your organization, some of them only allow certain numbers of resources to be provisioned. So you may need to spin up another instance. But in my case, usually two is enough. If I can consolidate, let's say I have a West Coast and an East Coast presence, I'll keep those separate. And that way I can, if one's compromised, I have the other one. That's really my approach to it. What do you think, Vasyl?
Well, I'm just thinking about it, and you might have an auto-scaling group, not just one instance, and it might scale in different regions. It might scale in different AZ availability zones, and usually people keep, like, when they keep growing, number of instances also increases, and you might be careful about what you're running on these instances, because nobody is. You still might be vulnerable to a SSRF
absolutely
kind of attack, yeah. Even if you have like auto-scaling group, and even if you put an application load balancer in front of it.
Yeah, absolutely. Regardless of how many instances, I always want you to be stateless, use an elastic load balancer, scale, set up for horizontal scaling, et cetera. Use those design principles and use that the ideas of really kind of setting up RDS with replicas and with read-only replicas, things like that. But yeah, to me, it's the idea of separating instances to different AWS accounts is only to protect from credential theft and access. Keeping in mind, and that's assuming you're keeping your IAM separate and everything like that. That's really only, let's say you have one instance that is super top secret and everything else for production is in the other one. If you have some logical reason to separate, then separate, but otherwise keep everything in the same instance is my point.
Yeah, and always follow least privilege principle. Never give over permissive access to a role that is attached to EC2 instance. So let me take this one. How can infrastructure as code scanning in AWS can be done? So I'm a big fan of CDK, which is CDK, Cloud Development Kit in AWS, and they have an amazing library, which is CDK-NAG, that allows you to scan your code before it gets deployed in production environment. So always use this opportunity to double check, your code and whatever is going to be deployed. So
awesome. Let's see, any other questions here? I see a couple in comments here. Let me see if any of them trickle up.
It will be like, from my perspective, it will also hear your thoughts. Okay, yeah, we have another question.
Yeah, what about having your own identity provider with MFA? So I actually prefer that. Rather than depending on AWS's IAM, just configuring users. I prefer to manage everything with an IDP like Okta, things like that. Just keep in mind that any other piece of technology also needs security and monitoring on it. So those Okta logs then need to go to a managed SIM provider like UnderDefense. So, regardless of what you're using for identity, you need to be on top of it. And there's still opportunities for misconfiguration there. But yeah, I'm all for using another IDP that is your central source of truth for managing access to environments properly. And when you have an IDP that's a great one, you're probably in a better situation to then control access to those top secret resources and things like that, and leverage that IDP for that. So my point of view is use that third party IDP if it's a good one with MFA, but make sure that those logs in that audit trail are going to manage SOC, and also make sure that it's configured right, and then do some kind of testing of it. If you're new to that IDP, bring in a consultant that is an expert in that IDP to look at it and make sure that it's secured the way it should be.
Yeah, it's always cool to have a third-party audit, on your work to get validation and positive feedback, which you can use further on your performance appraisal. While we're waiting for other questions from audience, I have more discussional question to you, Art. What do you think about companies who utilize a multi-cloud approach, and if that is more risk and exposure for companies rather than sticking to one reliable provider like AWS?
Right. Well, I think the hazard, the risk is that now your people need to have skill sets that encompass both or all three public clouds. If you're using Google Cloud and you're using AWS and you're using Azure, your engineers need to understand, how to architect for all of those environments, how to secure all of those environments, and how to manage those features. So to me, it adds more risk in skill set. I think management risk, you can do it centrally with various tools out there that are for cloud configuration management. And I've always been of the approach where I want to do multi-cloud, where I want to deploy an application that can run in any cloud, and I have some kind of centralized load balancing system. But then when that happens, you need to build an abstraction layer in order to abstract the calls to AWS or to Azure or to GCP, because the underlying infrastructure is different on each of those, and the API is different on each of those. So you need an abstraction layer. But so I think there is complexity, but it can be managed, and I think the risk is really that skill set. So if you don't have a team that has those skill sets across them, don't bite off that risk and just stay in one cloud and make them skill up in that one cloud, so that you can actually proficiently defend that environment.
Absolutely agree with you. Good. I believe if we don't have any further questions, we are always open to respond to any of your questions through LinkedIn. Feel free to contact each of us. And thank you for your time being with us today. Art, thank you for your brilliant thoughts. Vasyl, thank you for preparing all this infrastructure and demo and showcasing this scenario from real life. Thank you, everybody.
Thank you.
Keep your infrastructure secure.
As a code.